Okay, I'm going to start talking about 3.3 in the Algebra 2 Honors book, performing function operations and composite functions. First, we're going to do function operations. Function operations might be addition, they might be subtraction, they might be multiplication, or they might be division. And if it says to add, you add them. So I'm going to write down f of x, which is x squared minus 4, plus my g of x. And what is my g of x? X minus 2. So when I combine like terms, what do I get? I think minus 6. Does that look correct? And if you have f of x minus g of x, you have f of x, which is x squared minus 4. It's minus because I'm using the minus. Always use parentheses when you subtract. So this is x squared minus 4 minus x plus 2. Combining like terms, I think negative 4 and 2 combine to give you a negative 2. So if it says to add them, you add them. If it says to subtract them, you subtract them. If it says to multiply, like this one, you're going to multiply them. So let's distribute. X squared times x is x to the third. X squared times negative 2 is negative 2x squared. Negative 4 times x is negative 4x. And negative 4 times negative 2 is a positive 8. So that should be your answer. It's proper to put them in decreasing powers. So notice that I am arranging them in decreasing powers. And finally, if it says to divide them, I have f of x, and it's division, so I divide by g of x. I think the numerator factors into difference of squares are conjugates, x plus 2, x minus 2, in which case the x minus 2's might divide out, and it would simplify to x plus 2. Anyway, those are the functions of function operations. It'll either be addition, subtraction, multiplication, or division. They're going to give you two functions, and you perform whatever operation they give you. Next up is going to be composite functions. Okay, now we're going to talk about composite functions. I left the same f of x and g of x. X squared minus 4, and g of x is x minus 2. First, I want to find f of g of 3. Now be aware, sometimes it's written this way, f of g of 3. Now this little thing here in the middle should be an open circle, f of g of 3. I know it looks like fog, but it's one of the ways that they write it. I prefer the old style of writing it like this. I want f of g of 3. So first I need to find out what g of 3 is. How do I find what g of 3 is? Well, I replace the x with the 3. And what is g of 3? 1. So now I need f of 1. So how can I find f of 1? I take my f function and I replace the x with a 1. So I put a 1 in. 1 squared is 1 minus 4 is negative 3. So this answer should be negative 3. I usually say if there's a value, find the inner part first, g of 3. That's what I did over here. And then you want f of that, so you plug that into the f function. Now, you'll also get ones like f of g of x. What I recommend you do with these is look at the outermost letter f. What is it? It's x squared minus 4. That's what the f is. Then you're going to replace the variable with the other expression. So I'm going to put in x minus 2. That's what the g is. I take the f function, replace the letter with the other expression. Square the first, twice the product, square the last, FOIL it out if you feel the need. But if you learn the rule, it can be quicker. And there is letter B, f of g of x. How about g of f of x? What's the outside letter on this one? G. What's the function? Something minus 2. That's what the g is x minus 2. I'm sorry, the g is x minus 2. So I have to write something minus 2. Again, I'm going to replace the variable with the other expression. The other expression being x squared minus 4. And then all I do is simplify it. I think it becomes x squared minus 6. Now, if you ever do f of g of x or g of f of x, let me state this very clearly. If you ever do f of g or g of f of x, and your answer is just x, that means that they would be inverse functions. Now that's the next section we're going to be coming to, I believe 3.4. So I want to point it out right now so you can take a little time to ruminate or think about it, because when you're doing these composites and you just get x, that means they're inverse functions. I think an example I gave you might have been something like this. Let's make fx squared and g square root of x. What is f of g of x? Well, you take your f function, which is x squared, and you replace it with the other expression. Does it just equal x? That means they are inverse functions. Inverse functions have very special properties. Let me see if I can do this a little more accurately here. What does square root of x look like? Does it go through 0, 0, 1, 1, and 4, 2? Square root of x, does it go through 4, 2, 1, 1, and 0, 0? Well, the other one, g of x, which I'll do in red, what's the square root of, that is the square, I'm sorry, that's what this one is, so let's do this one in red. X squared, if I was to restrict the domain and say x is greater than 0 or greater than or equal to 0, its graph would look like this. Please notice that instead of going through 4, 2, it goes through 2, 4. In other words, you're switching the x and y values on inverse functions. Another interesting property of inverse functions is that they are symmetric about this line y equaled x. If, in other words, if I fold it on the line y equals x, these points should match up. Anyway, that's all about inverse functions. We'll be getting to those soon enough. Right now we're dealing with composites. Okay, that was the introduction to 3.3. The assignment is going to be 3.3, 3 to 33 odds, and we're going to work through select problems. Hopefully it'll help make sense of this.